Significant figures are a way to help us know how precise a measurement is, or how good that measurement is, because you want to be able to reproduce your experiments in the scientific community. So we need to be using the exact same type of equipment. So your numbers are going to be limited by the tool that you use. Whether you use a beaker or a graduated cylinder, you'll get a much more precise answer if you're using a graduated cylinder than you will for a beaker. So the significant figures in a measurement are going to include the known digits plus one estimated digit. So if we look at a graduated cylinder here, remember that you read the bottom of the meniscus for the graduated cylinder. You can read to the ones place. So this long line here is 50, this long line here is 60. So there's 10 lines, or 10 divisions here. So each line would be 1 milliliter. Then we estimate the final answer. So because our water line is not exactly on 53, it's just below, we report that as 52.9. Now if it is exactly on there, you would report it as 53.0. So what's the volume here? Read the bottom of the curve, your meniscus. Now in this case, each line is 0.5. So you're going to have to report to the hundredths place here. And this one does appear to be right on the line, so we would report that as 11.50 milliliters. Now there are some rules you're going to need to know for significant figures. First of all, any number that is not 0 is going to be significant. Okay, so in this measurement here, we have no zeros, so all 4 of those are significant. In 5.6 feet, we have 2 numbers that are not 0, so we have 2 significant figures. So figure these out. We have 3 here, and we have 5 here. So let's talk about the zeros. First rule is about what we call leading zeros. All right, a leading zero is a zero that comes before your number. Think of it this way. If you would not include this 0 in your scientific notation, then it is not going to be significant. So in 0.008 milliliters, or millimeters, excuse me, these zeros are all leading zeros. None of them are significant. So there's 1 significant figure. In this measurement, we have 3 non-zero digits, so those are definitely going to be significant. Here, these 2 are leading zeros. In this third example, we have 3 leading zeros. None of those are significant, so we only have 2 significant figures. And in this last measurement, we have 4 leading zeros. These 3 non-zero digits are all going to be significant, so we have 3 significant figures. Rule number 3, if you have a 0 between non-zero digits, they are going to be significant because that number would not be the same without them. We would not have 50.8 without that 0. So that 0 is what we consider significant. It's a sandwich 0. So this number has a total of 3 significant figures. The second one, 2001 minutes. It would not be 2001 without the 2 zeros. So those zeros are significant. So we have a total of 4 significant figures. Now in this example, we have 1 sandwich 0. But this 0 here is a leading 0, so it would not be significant. So this number would have 3 significant figures. Same thing in this example here. All right, we have our 4 and our 5, which are not 0, so they're definitely significant. We have 1 sandwich 0, so it's significant. These are leading zeros. They are not. Our next rule has to do with trailing zeros. Now, trailing zeros are placeholders. Again, these are numbers that you would not include if you wrote it in scientific notation. So 25,000 inches, these 3 zeros here are trailing zeros. We don't know exactly what this number is. Kind of like when you have change in your car, you might say, oh, I have about $2, but of course you don't have exactly $2. All right, so these zeros are not significant. This could have been 24,982. You know, we don't know exactly what that was, so we only have 2 significant figures here. Now in this example, it's 200 and the decimal years. That decimal indicates that this is exactly 200 years. So when you have a decimal point there, that tells you that these are basically sandwich zeros. So those zeros are significant. In this third example, 48,600 gallons, we have 2 trailing zeros. So they are not significant. So we would have 3 significant figures. And in this last one, notice we have a lot of numbers down here. So the 2, the 5, and this other 5 are definitely significant. These 2 zeros are sandwich zeros, so they are significant. These 3 are trailing zeros. They are not significant. So we have a total of 5 significant figures in this example. Finally, if you do have a final zero that occurs after a decimal, those are significant. That means that you have taken the time to make that measurement to that decimal point. Just like in our graduated cylinder, it was 11.50. We took the time to measure that zero, which makes it significant. All right, so we have 4 significant figures in this first example. In this second example, we have the 9 and the 8, which are significant. We have a sandwich zero, which is significant. And we have one final zero, which is significant. These 2 in the front are leading zeros. They are not significant, so we have a total of 4. In this last example, we do have our 1, which is significant. We have our decimal followed by a 0. So this is a final zero after a decimal. It is significant. That makes these 2 zeros in between sandwich zeros. So we have a total of 4 significant figures here. So here are a few questions that you can answer. You can pause the video because I'm going to tell you the answers here in just a second. Which answers contain 3 significant figures? Well, this first one, this is not a significant figure. We have 3 here, but this is a final zero. So this one has 4, so it's not 1. And number 2, these are leading zeros. They are not significant, but we do have 3 non-zero digits which are significant. So number 2 is an answer. And number 3, we have 1, 2, 3 sig figs. This is a trailing zero. Notice there's no decimal point here. So this is not significant. So the answer to A is 2 and 3. In B, all the zeros are significant in, not number 1 because we have leading zeros. In number 2, yes they are because we have final zeros after the decimal. And in number 3, yes they are because we ignore this part here. Scientific notation also helps us to determine how many significant figures we have. You always include all significant figures in scientific notation. So these zeros are both significant. They're final and a sandwich. And C, 534,675 rounded to 3 significant figures is going to be number 2 here, 535,000, or number 3. Because if we move that decimal point, we would get 535,000. So it cannot be 1 because that's not the same number. Using significant figures in calculations is important for us to report our answers so that we get the proper number of significant figures in our answer. The calculated answer cannot be more precise than the measuring tool. Your calculated answer has to match the least precise measurement. All right, you can only be precise as your least precise instrument. In other words, like if you're driving, you can only go as fast as the person in front of you. So you can only be as precise as the instrument that you're using. We also need to know the rules for when we add or subtract or multiply or divide. So when you add or subtract, you would need the same number of decimal places as the number with the least or the fewest decimal places. So if we were to add 25.2 and 1.34, we would get 26.54 in our calculator, but we would report our answer as 26.5 because 25.2 only has 1 decimal point. So in A, how many decimal places would we report? All right, we have 2 decimal places in this first number, 1 in the second, 1 in the third. So we could only report our answer to 1 decimal point. So that would be 2 is our answer. We do the same thing with subtracting. In our first number, we have 3 decimal places. In our second number, we only have 1. So we can only report our answer to 1 decimal place, which would be number 3. Now when you multiply or divide, you're going to round or add zeros to the calculated answer until you have the correct number of significant figures. Now you can only have the number of significant figures that is equal to your measurement that has the fewest significant figures. So for example, if we were to say 2.19 times 4.2, 2.19 has 3 sig figs, 4.2 only has 2 sig figs, so our answer can only have 2 sig figs. So number 2 would be our answer. In B, we're going to divide these numbers. So 4.311 has 4 sig figs, 0.07 has 1. So we can only report our answer with 1 significant figure, which would be number 3. Notice we've had to round. Now in C, we've got several numbers here. So 2.54 has 3 sig figs, 0.0028 has 2 sig figs, 0.0105 has 3 sig figs, and 0.060 has 2 sig figs. So we have 2 significant figures in both of these numbers here and 3 in these numbers. So our answer can only have 2 significant figures. So when you do your math, you do have to be careful about how you put this into your calculator, because notice 2 and 3 both have 2 choices. So what you have to remember is that you have to do all of your multiplication before you do your division. So if you were going to put this in your calculator, you would need to make sure you put parentheses around your 0.0105 times 0.060 before you put that in there. Okay? So if you put this in your calculator correctly, you should get an answer of 11. So number 2 is the right answer there.